If you strip away Earth's atmosphere, you get a frozen rock. Incoming solar radiation would simply ricochet back into space, leaving the surface at -18 degrees. We only exist because a thin layer of trace gases catches that escaping infrared heat, maintaining the exact global temperature that allowed human civilization to thrive. For millennia, that system maintained a strict chemical balance. Then, about 2 centuries ago, we began extracting millions of years' worth of stored carbon and pumping it straight back into the air. We tend to think of the sky as an infinite expanse. In reality, it is a highly sensitive, closed-loop system. When you alter the chemistry, you alter the thermostat. Every time we clear-cut a forest or burn coal, oil, and natural gas, we inject massive volumes of carbon dioxide, methane, and fluorinated gases into the system. This data visualization plots the accumulation of those specific gases against an energy retention curve. The amount of extra heat we are now trapping is equivalent to detonating 400,000 atomic bombs across the planet every single day. All that trapped kinetic energy has to go somewhere. Since 1880, it has driven the global average temperature up by 1.7 degrees Fahrenheit. The natural regulatory systems that kept Earth stable for thousands of years are now overwhelmed by human chemistry. We have pushed our planet into entirely uncharted scientific territory. The most visible casualty of this extra heat is the cryosphere. Because of a feedback loop called Arctic amplification, the poles are warming twice as fast as the rest of the planet, causing massive ancient ice sheets to fracture and collapse into the ocean. Beyond the influx of meltwater, there is a second invisible driver of rising seas. This diagram illustrates thermal expansion. As ocean water absorbs heat, the individual molecules gain kinetic energy and spread further apart, physically swelling the total volume of the sea. That same heat supercharges the global water cycle. Higher temperatures trigger rapid evaporation in some regions, creating brutal, prolonged droughts, while dumping concentrated extreme rainfall in others. Rising temperatures trigger a physical restructuring of the global climate. This change is altering the chemistry of the oceans and the fundamental mechanics of our weather engines. Those swelling oceans and erratic storms translate directly to coastal flooding. In low-lying cities and island nations, rising water forces communities to abandon their homes and salvage what is left of their local economies. Beneath the surface, the ocean is absorbing billions of tons of our carbon dioxide emissions, creating carbonic acid. This ocean acidification dissolves the coral reefs that support entire marine food webs. On land, the disruption is equally severe. Crops like these vast, sprawling rice paddies rely on highly predictable water cycles. When extreme heat and erratic rainfall replace reliable seasons, global food production is compromised. When crops fail and coastlines sink, millions of people have no choice but to move. Entire populations are projected to become climate refugees as their home regions become completely uninhabitable. The collapse of Earth's physical systems is a direct threat to human survival, global food security, and global economic stability. Our legacy infrastructure, built entirely on burning fossil fuels, is incompatible with the physics of the planet we inhabit. But the cost of solar technology is plummeting. Over the last decade, solar energy has become cheap enough to aggressively undercut fossil fuel alternatives, allowing massive arrays to supply clean power directly to the grid. That same economic shift is driving the construction of industrial-scale wind farms. To handle this influx of intermittent, clean power, nations are now upgrading to intelligent electric grids that route energy exactly where it is needed. Simultaneously, the global transportation sector is pivoting away from internal combustion engines. Mass electrification is bringing zero-emission vehicles from the drawing board to the driveway. Decarbonizing our economy is no longer a theoretical exercise. The engineering is viable and the hardware is deploying worldwide. But hardware cannot solve this alone. Transitioning an entire global economy requires carbon pricing, strict environmental policies, and unified international commitments. Even if we halted all emissions today, a certain amount of warming is already locked into the system. Governments must invest in smart development, reinforcing bridges, roads, and cities to withstand the extreme weather we can no longer avoid. The Intergovernmental Panel on Climate Change and thousands of global researchers have reviewed the data. The consensus is absolute. Aggressive mitigation and rapid adaptation are mandatory. Humanity is facing a stark choice. We can maintain our current emissions and trigger irreversible systemic collapse, or we can execute a rapid global transition to sustainable energy. The worst-case scenarios are entirely avoidable, but hitting that target means treating this crisis as the most urgent engineering and policy challenge we have ever faced.
Watch till the end? You'll love what's next. Subscribe, like, and comment for more amazing insights.